Hello guys, in this video we're going to discuss synthesis by function generation inversion method for a slider crank mechanism. In the previous video we have done for a 4-link mechanism, and in this we are going to solve a problem to explain the concept clearly. According to the question, we are asked to design a slider crank mechanism to coordinate 3 positions of the input and of the slider. They are given the data about the angular displacements and the lengths S12 and S13. For the first step, we have to draw two parallel lines which represent the hinged point and the line of travel respectively. We have to draw them at an appropriate distance, but here we have taken the eccentricity as 20 millimeters. We have to mark the hinged point as A. Now we have to take a suitable length AC1 and plot the point C1 on the travel path. Then we find out the points C2 and C3 from the given data that S12 is equal to 40 millimeters and S13 is equal to 96 millimeters, or in this case C1C2 is equal to 40 millimeters and C1C3 is equal to 96 millimeters. The points C1, C2, C3 all lie in the same straight line as the travel path. After joining AC2 and AC3, we are required to find the points C2' and C3'. Since they have given us the angular displacements in the question, we can easily find the positions of C2' and C3' by simply rotating AC2 and AC3 in the anti-clockwise sense. AC2 has to be rotated by an angle of 30 degrees so that we can find the point C2'. Similarly, AC3 has to be rotated by an angle of 60 degrees to plot the point C3'. Now we are required to find the mid-normals to C3 C1' and C1 C2'. Again, the mid-normals are nothing but the perpendicular bisectors, so we draw them. Upon extending them, we find that they meet at a point. Let's name this point as B1. Now, in the final diagram, we can observe that A1, B1, C1 are joined and they form the required slider crank mechanism for our question.